Hello, my name is Walter Unglaub, and this is Heat and Mass Transfer, a tutorial. Heat and mass transfer is deserving of at least one entire course at the college level to fully appreciate and understand all the equations and intricacies associated with the subject material. For the purposes of this introduction video, I can at least go over the topics and types of subject material that one would cover in a course. If we consider heat transfer one can think of as a type of energy in transit, where the energy that we speak of is typically denoted or typically viewed as heat energy. And there are three primary drivers or methods by which this energy can be transferred from one physical system to another. The first is conduction, and conduction describes the process of heat transfer when two materials are in contact with each other, and they are at different temperatures. So material 1 will be at temperature 1, and material 2 will be at temperature 2, and there will be a temperature gradient that's equal to the difference in the temperatures. And this temperature gradient is what will drive the transfer of heat energy between the two materials, or from the hotter one to the colder one. A second type or method of heat transfer is that of convection. And convection involves, again, two materials, but here, instead of direct contact between these materials, convection, for example, can involve a fluid or liquid that makes contact with a material. So here, this liquid, this fluid, the average kinetic energy of all the particles can be very hot, and that can transfer energy into this material, this slab of solid material. Or if the temperature T1 is greater than the temperature of the fluid, then the fluid will carry away the excess heat energy. The point is, there's still contact being made here, but we call this convection. And this convection can actually occur between different gases as well. The third common method through which heat is transferred is known as radiation. So, if a material is hot enough, it can radiate heat, or if it's radioactive, it can radiate radiation. So this material will radiate, for example, gamma rays if it's radioactive, or like a black body can have radiation and emit in the infrared spectrum, and another object will absorb that radiation and will excite the atoms on the surface of that material. So this is yet a third method through which heat is transferred from one object to another. What's interesting about radiation is it's not direct heat transfer like conduction and convection. It can happen at a distance. Finally, if we consider mass transfer, which is the other aspect to a course taught in heat and mass transfer, the driving force or principle behind the transfer of mass from one region of space to the other is that of a difference in the concentration of the mass. So mass transfer is driven by concentration difference of a particular species or multiple species, and the dynamics of this mass transfer between different regions in the material or different materials is and can be described by mathematical equations, in particular differential equations that describe diffusion. So we call these diffusion differential equations. And these equations describe the rate at which a particular species will transfer from one region to another. My name is Walter Unglaub, and this is Heat and Mass Transfer, a tutorial.